Welcome, everyone, to Empowering Your Team with Automation, Advanced Tools for Automating the Most Tedious Tasks. Hope everyone's having a wonderful GCAP so far, and we really appreciate you taking the time to come and take a look at our talk. I'm Matthew Deline. I'm a build and test automation programmer at Mighty Build and Test in Melbourne. I make cool things. Previously, I was the founder of Camper Van Games, working on the alternative controller arcade game Shape Arcade. I did a master's in independent games and playable experience design at Goldsmiths, University of London, and used to work in technical support for Apple worldwide operations at their headquarters in Cupertino. Here today with my colleague.
Sure, yeah. So I used to be the biz director at Harmonious, where I was there for about 5 years, where we worked on games like Putty Pals and various client projects. And yeah, I'm currently studying a Master's of Business at Melbourne Business School.
Awesome. Well, thank you very much for taking the time to speak with me here today, Joe. Without further ado, let's go ahead and get started. Our talk today is about automation. So we really wanted to get started by sort of defining our terms here. So automation as a noun is the technique, method, or system of operating or controlling a process by highly automatic means, as by electronic devices, reducing human intervention to a medium. So what does that mean? Like, why is that definition important? So automation can make things easier for your team so that they can focus on the work that matters most to them. So how can automation help your team? So there's 3 different ways really that can sort of, that we see as being the most important for getting this working: builds, repetitive tasks, and automated testing. So for builds and continuous integration, what that is sort of setting up a build pipeline to automatically create builds as you check in code or set things up. And really sort of like automating your build pipeline can significantly improve your team's process by eliminating the need to manually build and distribute from a work device. So that way you can have everybody on your team getting builds as check-ins are made so that people can test and play the game without having to do the process, which can be very time-consuming on their own. Speaking of, it's a repetitive task itself. Any other repetitive task can be anything that anyone on your team has to do manually, such as setting up editor tools for asset importing, localization, and data entry are some common examples for things that people do for repetitive tasks. So setting up scripts or other things that can kind of automate your workflow throughout the day that make things easier for developers to work. And automated testing, which is the focus of today's talk, where we will discuss some of the current available options for automated testing, how we approach designing our testing systems to maximize results. Okay, so what is automated testing? A lot of people can sort of think, okay, well, we've just defined this term automation. This is reducing human intervention to a minimum. If we're setting up testing, we want to be testing our games to make sure that they're doing the correct things that we're expecting them to. But you might be asking yourself, well, isn't that sort of QA's role? Or, you know, in terms of sort of like what's actually getting these games working correctly? And I want to make it absolutely clear that automated testing is not a replacement for QA. QA is super important. And what we're really doing here is sort of automating the most tedious parts of the testing process so that QA can focus on more human qualitative concerns, that sort of, how does the game feel when you're playing? Is the difficulty curve correct? Is more design related issues that are way better suited for human interaction than tedious repetitive tasks that automated testing is really good at. So we arrived at our own definition for automated testing versus just automation, that automated testing is an automated system of operating or controlling software, either through the use of error checking methods from within the code base or via simulated inputs and behaviors. So now that we know what automated testing is, I'll hand things back over to Joe to talk a little bit more about what things are available.
Yeah, thanks, Matt. So yeah, there's a bunch of stuff out there. Unity is starting to play around with it a little bit themselves with their automated QA system they've just kind of released recently. Mostly focuses on UI testing and kind of recording tests. So where you as a tester go through and like click on a bunch of buttons, then record that, and then you can replay that in the editor to test that everything's working. It doesn't really go anything beyond that just yet, but I know they have plans to do it. Air test is pretty similar to Uni in that regard, where it mostly focuses on UI games and mobile games, since that's what NetEase, the developer, works with. So they do have a really cool tech around image recognition, where if you move buttons around, it knows what that button is, and it can kind of keep track of it that way, which is kind of handy. Then there's Unreal, which it's an internal tool that isn't super well supported, but yeah, it kind of allows you, in a similar way to Uni, kind of get in there and like work with the Unreal libraries and design your own tests that way. Then there's Mighty Build and Test, where our approach is we have the advantage of being able to go into the code base itself, so we can go a little bit deeper than some of these other alternatives. So we do UI testing, but we mostly focus on like gameplay testing, kind of interacting with the code base itself, developing kind of behavioral models and decision trees and all that kind of stuff. And when we do UI testing, it's mostly about teaching AI to press the buttons in a game, and then we kind of just let the bot figure it out from there. So it's a little bit more robust. It doesn't break if things change. And then there's a bunch of other solutions out there as well that I won't go into, but it's definitely a growing field of automated testing in games. Yeah, so what does automated testing do really well? So like I said before, like there's a reason why a lot of these other solutions have started with UI and menu, because that's kind of the immediate, it's quite easy for computers to do, where it's kind of defined actions about pressing, and it's very simple and easier to write procedures for. There's also unit testing, which is something that's not super used in games, but automated testing does allow you to do it to varying degrees. And then there's also smoke tests, which similar to what I discussed before with the UI testing, except then kind of built out beyond UI into actual gameplay itself. So getting a character to move around on the screen in a pre-recorded way and getting to do certain actions and stuff like that. And so you can think through, like, if you have enough of those tests and running one after another, like you can kind of get to the point where you have reasonable confidence in your game's quality, as long as all these tests are kind of passing. Because a lot of traditional software uses unit testing for this kind of thing, but because of stuff like physics and a lot of UI graphical issues and stuff like that, unit testing isn't quite as applicable to games, and that's where like stuff like smoke testing works really well. Cool. Yeah. So then the challenges with automated testing. So while it's really great at some of those simple examples we described before, this is where it starts to get a little bit more challenging. Definitely not unsolvable, but these are areas where you have to spend a little bit more time. You have to be a little bit more intentional with how you go about it, just because it can be such a big time sink. So anything like complex systems like multiplayer, anything where like you have kind of 3D movement, generally anything where if the AI fails to get back to the point where it can retry again is difficult. So say like a platform, if it falls off a platform, to get back to try that again that's quite complex for AIs to be able to do properly. Also, if your game doesn't have any AI built into it to begin with, that makes it quite difficult. So both from a technical implementation point of view, where you just don't have any code in there you can leverage yourself when you're writing these tests. And also you may not have designed to expose certain data and all that kind of stuff. Like it's something that makes it a little bit harder to kind of retroactively go back and do later on in the process. And then, yeah, large possibility spaces. So like stuff like big worlds, stuff where you can just like if you just let the bot go and have fun and get lost, like there's just too much kind of going on where like you just don't get much out of it unless you're like a really specific about the kind of testing that you want to be doing in those kind of large possibility spaces.
Great. Thanks very much for that overview, Joe. We'll be talking now about designing for automation, just in the idea of what steps or what tools can you use to sort of make your games ready to be able to test or sort of like automated tests. And that really starts with sort of asking the same kinds of questions that you would be asking yourself when you're thinking about doing human testing. So what are you testing for? So we ultimately want to capture the same errors and results that you would otherwise be checking for. So this is your first step here. Like, okay, well, do I want to see if the progression flow is working? Can I complete the game? am I able to open a menu? Can I push the exit button and it doesn't crash the game? Do I have graphics settings? All kinds of different things like that. So starting with that, sort of like go through sort of like what I'm calling kind of the tool set or the tool chest here. And there are 3 tools that we'll talk about. The first tool here, log exceptions, errors, and asserts, sort of like, at least in the nomenclature here, is a very Unity-centric approach, because you can have a debug.log exception, debug.log error, and debug.log assert. But the concepts themselves are available in a number of other programming languages and tools as well. So the idea really here in this case is we're using these exceptions, errors, and asserts, which is a very good way to sort of put aside as a way for, in sort of like general testing, you can use them as breakpoints or otherwise, but a way for you to know the kinds of things that you need to go back and fix later. So in this case, we've got a screenshot of one of our test bots that run automated testing examples of different games. In this case, playing one of my games, Piffle. And there's a bunch of red on the screen there, and that's not good. But what that is basically telling us that we need to sort of fix that. So we'll have a reference for what is being output in those debug log errors that we can go back and check later and fix them so there's no red. So that's really sort of like the big first tool set that you've got the ability to do, is sort of using these logs as a way to sort of breakpoint or sort of like give yourself an idea there. Some of the more complicated or complex techniques that you can use with these types of things, like especially with asserts, are ways to validate in your code whether or not things are occurring the way that you expect them to be doing. We've seen a number of examples where people are trying to find out, okay, well, if I push a button or if I beat a level, does my score go up the way that I expect it to within the text fields? And one of the great ways that you can do that while you're sort of going through and setting up your game code itself is to sort of build in a check that would fail if, say, for example, those values aren't being updated or saved properly in the way that you would expect. And that's a really good way to sort of use the game code itself to do this testing for you without having to have that testing process occur on its own. And that will save you heaps of time in the long run. So with that said, the other second thing that's really important for automated testing is setting up a set of virtual input. So right now we've got 3 different examples here. Touch. In this case, we're looking at Fruit Ninja, sort of like where someone's slicing on the screen, except it's not someone, it's our little test bot. On the second example, we've got Piffle, which is actually playing Piffle Switch. In this case, it's using gamepad controls to approximate the movement and otherwise. And the third example is from Shooty Sky's Overdrive, where we used the sort of automated testing to sort of pretend like it was a human by moving around the hand controllers and the headset, just sort of approximate human movement and attack the enemies in the game. And the way that you would do this, or essentially the way that you'll be able to set up virtual input for your testing system, if you're doing this in your own games or using an external tool, is to set up something like a wrapper, or the ability to sort of take the input system that you're currently using and put fake input into it. So if you're using something like Rewired, you can set up a custom controller that sort of sets the Boolean values that sort of say, okay, well, a button is down, or I'm pushing something on the screen, or touch inputs on the screen, or in the case of, say, for example, like Shooty Sky's Overdrive, we're saying, all right, well, this Oculus grip controller or sort of trigger is being pressed, even though there isn't actually something being pressed. And that's the core of sort of making automated testing work, is because we want this to be as close to the human interaction without actually having a human have to push the buttons themselves. So without further ado, our final tool is AI behaviors. And this is one of my very favorite stories that I'm really excited to share here. It's a simple example. It's sort of like it's something I remember from being a kid, and basically sort of like started off as this idea where, my dad was trying to teach me, okay, well, what if you wanted to give a robot, or tell a robot, in this case, our test bots or your automated testing system, and I promise this is going somewhere. So the idea really sort of like, okay, well, if you wanted to tell a robot how to make a peanut butter sandwich, How would you do that? So, all right, well, let's say your robot knows what a jar of peanut butter is, right? And your robot also knows what a piece of bread is. So, Joe, actually, what's the first thing you would say if you just wanted to tell a robot to make a peanut butter sandwich?
Yeah, I'd probably say get the peanut butter and put it on the bread.
Right? Yeah, right. That didn't work. so I mean, like, really sort of like the idea here is that what we're talking about, these AI behaviors that we're really creating in automated testing are sort of like, okay, well, how do you approach this problem of making sure that your games understand all of the components that are necessary to make your game work? So, say for example, UI is a very sort of common example. Like a lot of the automated testing examples that Joe mentioned earlier have a shared language in the sense that they've got similar UI systems like pressing and clicking and moving and sort of things there. But what if your game sort of like, you've got peanut butter, you've got bread, but you've got no knife? It doesn't work. Not at least the way that you expect. So you have to be able to sort of tell your game what those things are. So in this case, we're looking at an example of Piffle. So what we would go into when we're defining behaviors or AI behaviors for your game is sort of like, okay, well, does the game understand how to throw piffle balls? Does it understand what a piffle ball is? How does the game understand what the best choice is for that time? So the thing is that what you'll need for any of this stuff to work is a good understanding of the requirements for each of those actions so that you can replicate that within automated testing itself. And oftentimes that can be exposing values, or basically exposing public variables so that you're able to sort of recreate those later and access those from a automated testing standpoint so that you could know what the best place to shoot in the area is, or what button to press is, or how do I know what kinds of things I can purchase on the store, or what buttons I can press in the settings panel, just to make sure that your games are sort of playing the way that you expect them to and have the ability to do that. And that's kind of like how we approach design for these. What is our workflow here? And this is kind of how we approach and understand sort of like what we think this whole automation thing does. And it sort of goes through a 3-step process from building to testing to fixing. So building, it's a cute little robot here. Testing, which is where we'd start seeing the red text appear again. And fixing, which is when the red text is gone. Cool. So now that you know heaps of stuff about how to sort of design those, we'd like to go over a couple of case studies on some of the things that we've done ourselves that we found really interesting that might help others that are in those situations learn how to solve them as well. So without further ado, I'll hand things back over to Joe to talk about our first case study.
Awesome. Thanks, Matt. Yeah, so our first case study is going to be kind of on like the bread and butter, like I said before, on automated testing, like 2D and UI-based games, such as Piffle. So yeah, I just wanted to introduce the concept of coverage testing, which is making sure you test every part of your game in random ways a lot. So yeah, this kind of relates to testing menus and settings. So the way we kind of do it is you get the bot to understand where all the buttons are on a different screen, and you just make them press them in random different orders, go back and forth between different screens, make it change different settings, all that kind of stuff. The stuff that your players will probably do, but you may not naturally do kind of as you test. Kind of carrying forward to testing UI, so inventory systems, all that kind of stuff. Like the bots are really good at equipping and unequipping every item in its inventory over and over and over again. And so yeah, it's something you may not think to test where you're going, but hey, it's a really good way of like testing how robust your system is overall, because the bots are really good at ignoring your tutorials. And then finally, gameplay coverage testing. So This is kind of the way of designing the bots in specific ways to kind of test the space of a game, if you will, in different ways. So I'll just go to an example of that. So one of the things we did in Piffle was we kind of have the concept of what we call smart bots, well, what I call smart bots and silly bots. So as you can see, the smart bot on the left here, it scans through the level and kind of figures out what the best move is and then does it. So that kind of bot is really good at testing out the progression system of your game, kind of playing against like time consequences, different like limited numbers of moves, just closer to what an actual player will like hypothetically be playing like. And then we have silly bots on the right, which is where it just throws it in any different random direction and just hopes for the best. So again, like the silly bot kind of captures like that randomness of, I kind of call it PAX mode, where we've all experienced having somebody come up at PAX and play a game for the first time and they play it in ways you'd never thought possible. That's kind of what silly bot does. Like I still chuckle sometimes watching it play the game in certain ways. And yeah, it's just good, like different kind of, there's obviously even more ways you can do it, but these are kind of like the two ends of the spectrum, if you will, of like the kind of ways you can go about designing your bots. And again, like I said before, it's about designing it with like a very specific goal in mind. Cool. Yeah. So we won't dwell on this too much, but we thought it'd be really kind of handy just to show you like the kind of more economic power of automated testing. So on one of the projects that we did here at Build and Test, Matt and I did some like kind of napkin arithmetic and figured out that it was like basically 23,000 hours of testing, which on one machine, which was a Mac Mini. And so roughly working that out is like $30 an hour for a QA dev. It's like $700,000 Australian of like to pay a person at the equivalent of doing that. Obviously, you're not going to be getting a human to be testing for 10 hours a day, 4 games at once. That's a little bit ridiculous, but and obviously the kind of testing you get out of a human versus a bot is very different. But it's kind of like, it just shows you like just the amount of testing you can get out of a system like this, where you're running it overnight and stuff like that. And also, yeah, the fact that it found over 1,000 unique bugs, and that's not even including all the ones that were found by humans just watching the streams, which yeah, impossible to count. Moving on to the second case study. So yeah, like we spoke about before with the challenges. So this is where we kind of wanted to tackle or show you kind of like how you can dive into the stuff that automated testing isn't like kind of naturally super good at. So yeah, moving on. Yeah, so the way we like to go about it is just thinking of like the cheats and shortcuts that you can give your bots, kind of like you would give normal QA anyway, but just like really thinking about it from that kind of procedural, just getting the bots to do exactly explicit things that you want it to do. So if it's stuff like waypoints, if you have a game where it can explore a world, just sometimes rather than letting it randomly try and explore it, sometimes it's just easier to give it a set of waypoints and have it just go between those points. And that way you can kind of know, yeah, if your story works, the progression works, you can make it between all these points. There's totally nothing wrong with doing that. Teleportation is another thing as well. Like just if there's a certain area of your game you're a little bit more worried about, there's no reason why you'll have to wait for your bot to get to that area of the level every time as it makes its way through. Just teleport it there and let it play in that space specifically. Because again, that's where you think the issues are. So like you're a human and you're testing, just get it to like focus in on that area. And also stuff like cheat modes, like just sometimes give your bot a hand and give it infinite lives. Like they're very good at failing and dying sometimes. And so, yeah, just stuff like that can just make it so much easier. So it's not resetting as much. You're not covering over the same sections of levels or the story as continuously. And again, stuff like infinite currency as well. If you got an in-game store, it's good, yeah, to give it infinite currency so it can just download all the skins or all of the different unlocks and all that kind of stuff. And yeah, again, it's not limited by yeah, going through the whole progression system every time. And yeah, so basically the more succinct way of saying all that is design your bot to test your game, not play your game. Because I mean, that's the other day. That's what we're not writing AI players for your game. We're writing automated testing for your game. So it's just, sometimes it's gonna get easy to get carried away. So it's just, that's good to have that in mind. Because randomness, yeah, you need to guide the bots basically.
Yeah, and there's a balance between sort of complete open-endedness and sort of like holding it by the hand in order to be able to get them to test your game effectively. And that is I mean, it's worth talking about because I think that is the most difficult thing we've had to deal with.
Yeah,
by far.
Cool. Yeah, so like I kind of covered a little bit, but it's just all about focusing on, it's about kind of the 80-20 rule, just putting in 80% of your work, your effort into the 20% that you're most worried about. So parts of the game that change the most, where you don't want to have to be going in and testing every single build that this area of the game works, just let the AI do that if it's something that it naturally will do well. Yeah, and again, like stuff like menus, stuff like if you're just sitting down and play testing the game to make sure it runs, just the different areas you want to go into, those more obscure parts, just hand that off to the AI. It's really good at being able to just like compartmentalize and just leave it and just know it's being handled by the system you've already built. And yeah, finally, like the parts of the game that are just most prone to issues, because it can take some time to set up these automated tests, particularly for more complex types of testing. And so, yeah, it's just all about focusing in on, most bang for buck, basically. Cool, yeah, so that's how you can kind of take on some of the more challenging parts of automated testing. And I'm going to hand it off to Matt for our final case study.
Great. Thanks very much for that, Joe. This is definitely one of my favorites, mostly because it's pretty relevant to a lot of us. So our third case study, pivoting to work from home, getting your tools to do remote work for you, is really a lot about the struggles that we've had to sort of approach and deal with over the past, I can't even remember how much time this has been since sort of like 2020 kind of happened, and really threw a wrench into the way that we had been working and the way that we sort of thought a lot of these tools would work. So a lot of the stuff that we've learned here, I think would be really helpful in general for a lot of other people. So the first thing I'd like to show you is what the Mighty Offices looked like before coronavirus. Cameo from Mr. Ditton here, just kind of walking by. But what we had is a test wall, is what we called it, is a wall of monitors that essentially we would have up, and we would look over and be able to see throughout the day whether or not that red text, that wall of red text that we talked about earlier in the sort of log error section, would give us an idea, okay, well, hey, there's a bug out there. Let's fix that. It's stuck. It's not working. We'll be able to fix that. So what happens sort of like when you can't look at this wall of monitors anymore because everybody's at home and nobody has the same ability to do that? What we really had to think about is like, okay, well, what are the things that we need to do to make that test wall work at home? And we sort of came across sort of like three sort of major areas that sort of made things work for us a lot easier, to make that also work for everybody else that we were testing games for and sort of working with, to have them also have those access to that kind of ability to look at the stream and see the red and find the bugs. Actually ended up working out better, in my opinion, because now they have access to looking at that test wall instead of it just being us. So the first thing we did was testbot streaming. So we were able to sort of have these sort of like game instances being run and played and automated testing, but we used open broadcasting software to set up a custom output stream in a way to sort of like bring that experience home. We also did automated bug reporting. And this is a process that we've been iterating and improving over time, that started by sort of like capturing these bugs, those log exceptions and otherwise, or custom bug errors for different games, that would be sent in a chat message or included in that stream. And we've also been working on sort of like other extensions as well, like how can you also sort of find ways to make these things useful for you if you don't have direct access to these computers. And some of those things that we found is sort of like historical statistics in terms of like build statistics, your performance for the game itself, sort of over time, whether or not the frame rate is being stable. A lot of people use Jira as ways to sort of track bug issues. So how do you sort of integrate that bug report that you're getting, and how do you make that into a Jira issue? And sort of found there are ways to do that using the Jira REST API. And really sort of like a lot of other tools that sort of allow people to integrate the results from these into actionable pieces of work. So just to sort of give an example of that, this is what a streaming page actually looks like for Fruit Ninja, where we sort of have that stream and then sort of like back sort of like scrolls down and shows you a number of errors that are individually clickable, and you'll be able to see them sort of go through. So we found that sort of like, again, we're not telling you, hey, you have to do this exact solution here, but having a computer that might be running your tests that is running a stream that your entire team can watch can be really useful, especially when working from home across different time zones. You know, just making that connection a lot better. So anybody that basically on the team has the ability to watch the stream and sort of iterate or find these bugs or see these things just like we were when we were watching the monitors on the wall. Cool. So speaking of working from home, we were approached by our friends at League of Geeks with a really interesting problem that they needed to solve, which was testing their new crossplay multiplayer platform update for Armello. And how were they going to be able to do that when people were all stuck from home? They couldn't get access to the equipment that was in the office easily. If you wanted to test on multiple devices, and how do you approach this idea of getting multiple people to play multiplayer games against each other when you don't have regular sort of consolidated, centralized access to equipment? So what we're doing here, and we'll sort of go through sort of like talking about the problem that we've got, how we sort of approach that problem, and sort of like how that helped get across the line on this new crossplay multiplayer update that they've been working on. So the first step that we really needed to do was like, okay, well, we've got this game, sort of like Armello, that already had a suite of built-in AI. So when we were talking about earlier, it's a very complex game. So not having that system available makes that a lot harder to do, but being able to leverage that allowed us to sort of focus on getting the actual distribution to work. So the first step that we had to do was get the game playing and sort of like getting it to work on individual devices. So on Xbox or PlayStation or on Windows, just making sure that that'll work. So once we had that done, Scott Becca, who is a member of our team at Mighty Build and Test here, created a really interesting solution that allowed us to sort of manage the deployment from a centralized device to sort of like talk to individual builds. So rather than just having a test bot just automatically testing and just you'll be able to visually watch this, it actually captures the bug reports and the other things that we've been doing in other situations, and sort of gets it to a point where we're actually able to do something about that at a later point in time. So he created what he's called a proxy test bot system that uses a sort of PC or a Mac in other cases, sort of like where it's able to sort of take and manage the distribution onto various consoles or iPads or Android devices. And as new builds are made, sort of like puts them on there and sort of captures the bugs and sends them out, as we've been doing as well, and has the ability to do the streaming stuff that we've been doing as well. So that allows us to essentially sort of get these different devices to play against each other without a person actually being present. So I've got a really cool video to show you of a Switch build playing against a computer. And they're playing the exact same game there, which is really kind of neat. So they're connecting there. So what we did was basically sort of like, okay, well, we took this system, we've got this that works, right? And then we had to scale upwards. So how do we get as many of these are? And that's one of the advantages of automated testing is we're able to sort of put additional resources quickly based on having sort of like more Xboxes or PCs or otherwise available to sort of play multiple games. And the PC games especially sort of like we're able to run multiple games and multiple instances on the same device. So what we ended up doing was sort of setting up a complex system of different games playing against different platforms so that we're able to sort of validate some of the server updates that they needed to do as far as the submission was concerned. So one of the main things that they really had to approach with was a transition from UNet to Hazel and DTLS networking services that was causing issues, and they needed to make sure that they were able to validate and test. So what that looks like is an example here. This is multiple games sort of playing each other. And as we sort of like were able to scale that up, the more we were able to sort of get those games playing against each other with no one actually being present, the more we were able to sort of make sure, hey, these solutions, as we're making fixes, as they're being deployed automatically, as they're being tested automatically, this whole process is being done without much human intervention other than somebody committing changes to the code, makes that whole process a lot easier for someone on the team to be able to do. So we're really happy with sort of like how that whole process has went, and sort of gave us the opportunity to sort of get an idea for us for what we think the future sort of like working from home is. So moving forwards here, this is an example where I've got 9 games of Piffle playing on my computer, as well as on my iPad, and that's all being driven from my MacBook. And sort of like, I'm not expecting everybody to sort of say, okay, well, if I'm automating testing at home, I'm going to have a setup like this, but the ability is there to sort of utilize your resources effectively to do interesting things. And that's one of the things that we're so excited about what we do, about what we think automated testing is, and how we find this can really empower your team to do the best work that they can. So yeah, so without further ado, I'll pass this back over to Joe, who's going to give us a little bit of a review here.
Cool, thanks for that, Matt. So yeah, I'm just a quick recap of what we chatted about today. So kind of went through what automation is and what automated testing is, the different tools that are out there for you, whether you're using like Unity or Unreal or some of the other third-party solutions. The importance of planning early. So like most things in game dev, the earlier you think about it, kind of the better off you're going to be. The different kind of testing you can do, whether it's coverage or testing specific things. And then, yeah, finally, how complex it can be to do like proper kind of game testing AI. And so, yeah, just continuing on to where we kind of think automated testing is going. And so this is all very like pie in the sky, very forward-looking stuff, but we thought we'd just throw it in there to get you all as excited about it as we are. And so, yeah, it's just stuff like using kind of machine learning agents and neural networks to get the test bots themselves to play the game in a more organic way and kind of learn to play them themselves. The idea of using AI to automate the detection of bugs, and then using machine learning to detect error states, so we're not relying as much on error logs and exceptions like we are at the moment. Yeah, and then finally, virtualization and cloud deployment of automated testing. So this is where right now we run, at least for what we do, and we imagine what's probably what you'll do as well, is you run it on local devices that you have yourself, but ultimately it'd be great to be able to hand this kind of stuff off to AWS, who are kind of like the cloud infrastructure platforms that exist. And that's where you can really start to get like a decent amount of scale. But right now it's a little bit too expensive. Cool. Well, thank you so much for your time, and here's how to get in touch with us.
Yeah, great. I'll just chime in here. I really appreciate you taking the time to watch this. If you have any questions, please feel free to ask them in the chat here, and reach out with us if you have questions later that you haven't gotten a chance to ask now. Have a wonderful day.